Hi, I'm Doug Bailey from Power Integrations, and I want to talk to you about getting rid of heat sinks. Heat sinks are a fixture of power supplies, have been for an awfully long time. The amount of heat sinking required depends on the technology used, and that's evolved over the years from linear power supplies, which were very inefficient and required a huge heat sink to get rid of wasted energy, all the way through the 80-plus era of power supplies for PCs and computing equipment, into the most recent decade where laptop adapters were still quite large and bricky, but represented a very good cost-benefit trade-off. And now with the new GaN technology, we're able to build power supplies that are very, very highly efficient and don't require heat sinks at all. How do they do that? Well, this is a rather complicated diagram, but what it shows is the trade-off between switching losses and conduction losses of a MOSFET. And it's a fact of physics that as the device size increases, your conduction losses will drop because now you've got more area of transistor, more channel to conduct. But your switching losses go up because the capacitance of the device goes up, and the switching losses are proportional to the CV squared equation. So there's really a limit to what you can do with MOSFETs. Eventually, you bump into the laws of physics. Well, GaN changes the equation because as device size gets bigger, obviously your conduction goes down, but your switching losses go down. Don't increase at the same rate. And so what you end up with is a completely different power curve, and that gives you a fundamental advantage that MOSFETs just can't beat. And that means you can use more channel, more conductivity without the penalty of increased switching losses. These are some statistics on the PowiGaN switch that we manufacture. And as you can see, the RDS on, specific RDS on, is very low. The COSS, once again, specific COSS, very, very low. And we can also switch faster, which is a wonderful benefit. So that allows us to build power supplies for applications well beyond the classic laptop adapters. We're involved in building power supplies for consumer products, TVs, really anything you can name can benefit from GaN. Not only do you see increase in efficiency and reduction or elimination of the heat sink, but it's also more robust than silicon because GaN doesn't have the sharp avalanche that you see in silicon MOSFETs, so they're robust against surges and swells. I look forward to talking to the other panelists, seeing what they have to say today, and thank you very much.